In this video, we will be demonstrating sympathetic vibration, which is an indirect excitation of a body due to matching resonant frequencies. It can occur not only with a fundamental, but also with other overtones in its series.
So first we will have the clarinet play the same note as the piano. So they're both playing the fundamental. In this case, it's a concert D4. Now, if we add the semitone above and below it, no noticeable difference. Through sympathetic vibration, the clarinet is able to sound the same note on the piano when that damper is raised. Let's take a look at why. When we play a note, what we actually hear on most instruments is the result of a complex waveform made up of pitches from that note's overtone series. Here are the first 9 overtones in the series. The intervals noted below indicate the interval above the previous note. You may be familiar with this example if you've taken Introduction to Music Technology at UBC. Note the difference between a harmonic and an overtone. An overtone is any note in the series above the fundamental, while both the fundamental and all its overtones are harmonics. For the next demo, we will use D3 as the fundamental in an overtone series. These are the first 5 overtones of the fundamental. Remember, the first harmonic is the fundamental, while the second harmonic is the first overtone. As such, an overtone series does not begin with the fundamental, but the harmonic series does. Let's go back to the clarinet and piano. An interesting aspect of the clarinet is that its cylindrical design results in the odd-numbered harmonics being more resonant than the even ones. See if you can hear the difference. Let's hear the first overtone, D4. Second overtone is an A4. Third is a D5. The fourth is an F sharp 5. And the fifth is an A5. Let's imagine we were to pick up some instrument and play a concert pitch D3, but instead of only pitches in the standard harmonic series, we actually heard all of these pitches. All these notes are then partials of the fundamental. The ones that are part of the harmonic series are harmonic partials, while the others, represented here by squared neumes, are inharmonic partials. In a complex waveform, any resonant pitch above and including the fundamental is a partial.
So in this demo, we will witness sympathetic vibration caused by the clarinet on the guitar. To see this closer, let's insert a piece of white paper underneath the strings, as such, and we will zoom in.
The first note we will hear is D3, and this should cause the third lowest string to vibrate sympathetically. The next note is E4, and this should cause the highest string on the guitar to vibrate. As you'll see, the lowest string on the guitar, which is E2, is also vibrating because E4 is an overtone of E2.
A good example of a piece built on the concept of non-musical resonance is Alvin Lucier's I'm Sitting in a Room. Sympathetic vibration doesn't just happen in musical terms. It happens everywhere, from singing wine glasses to a roiling suspension bridge